Welcome back, everyone. We're going to continue our discussion right where we left off for part 2 of DataFrames. Let's get started. Okay, here we are with our notebook where we left off last time. What we're going to do is now talk about conditional selection. Just like we could with NumPy, we can perform conditional selection on a Pandas data frame. Let me show you what I'm talking about. Here's our data frame, and let's imagine we quickly wanted to know where's the data frame values greater than 0. To do that, I can simply do a Boolean comparison on the entire data frame. And since the data frame is built off a series, which is built off of NumPy, this works. It just broadcasts this to every element. So we have true, 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 false, etc. Now I have a data frame of Boolean values. So what I can do is use this Boolean or this data frame of Boolean values as a conditional filter by passing it into the data frame as my selection criteria. So I can say df bool for df booleans is equal to df greater than 0. So again, here's my data frame of booleans, and now I'm going to pass that in to my data frame. And note what now happens. It only returns back the numbers that were greater than 0. Everywhere else now gets not a number. Now, typically, you don't see this done in 2 steps. Instead, you'll see this. You'll say df greater than 0. And you'll get this sort of result. Now, what's really common, if we take a look back at our original data frame, is to actually filter off the conditions based off of one singular column. For example, here we have the column W. Let's imagine I wanted to only get back the rows for a particular condition on W, maybe where W is greater than 0. So right now, W for row C is not greater than 0. So I want to filter out my data frame for everything where W is not greater than 0. So essentially, I want to get rid of row C. However, let's imagine this is a huge data frame, so I wouldn't be able to manually look up the rows C. So instead, I'm going to use conditional filtering. I'll say dfw, where is it greater than 0? And this returns back a series of booleans indexed by the same original index of our data frame, A, B, C, D, E. And now it says true, true, false, true. So what I can do is I can broadcast this selection of rows across all my columns in my data frame, simply by passing in this condition into the data frame. So when you run this, it's going to only return back the rows that happen to be true for this condition, which is rows A, B, D, and E. And this is something really common, and you will see this all the time with Pandas. And then if you wanted to keep doing selections off of this, maybe you only wanted columns Y or column Z. Since this is a data frame, you can simply keep stacking your operations. And it gets a little hard to read, especially if this is your first time with Pandas, but stacking operations like this is super common. And then maybe you'll even see a further stack like LOC for row A. And then you get back that individual value. So at first, this is really hard to read because it's just kind of one ugly one-liner, but as you get more and more used to Pandas, you'll get more used to the idea. But right now, the thing you should understand is we created this series of Boolean values per row, and then we cast it across the entire data frame. Let's imagine that we want to have 2 conditions or more. For those 2 conditions, we simply say df, let's go ahead and set up 2 conditions, df of w greater than 0. So we'll say this is condition 1, and then we'll say condition 2 is equal to df y greater than 1. So we have these 2 conditions. What I can do is I can attempt to pass them in to my data frame. I can say where condition 1 is true and where condition 2 is true. And if you try to do this, you'll actually get an error. So it'll give you a value error, and it says the truth value of a series is ambiguous. And there's a whole discussion on this in the documentation, but basically the and or keywords that are built into Python, those are actually not designed for series. Because remember, condition 1, if we were to take a look at this, it's an entire series of Boolean values. Python's built-in and or operations aren't designed for that. They're just designed to compare one Boolean to another. So what we need to do is edit this for Pandas. And the way you edit this is for ands, you use an ampersand, and for ors, you use a pipe operator. So we set up the ampersand, and then what Pandas also requires is for you to wrap these separate conditions in parentheses so we don't get confused, or so Pandas doesn't get confused. And then when you run this, you get back the single row where those conditions happen to be true, which is just row E for each of these columns. And as I keep mentioning, typically you don't see this in multiple steps like that. Instead, you'll just cut these out and replace them like so. And then we'll just delete these two variable assignments. And this is the same thing. Again, a little hard to read if this is your first time doing Pandas, but hopefully you get the logic here. I have this series of Boolean values and this series of Boolean values, and I'm checking where they're both true across the entire data frame. So that's how you can do conditional selection with Pandas. Finally, let's get a little more detail on the index. So here I have my data frame. Let's imagine that I actually want these values, A, B, C, D, and E, to be a column instead of being the index. If I want to reset the index, I simply say df dot reset underscore index, run that command, and here I can see the index has been reset and is now a new column called index. Don't be confused by the term index here. That's just Pandas' default name for the new column set off of the index. Something to notice, just like many other Pandas methods and attribute calls, is if we call back the original data frame, this reset index was not in place. So if you do Shift Tab here, again you'll notice that there's an in place argument by default set to false. So we didn't actually affect our original data frame unless we absolutely want to. Next, what I'm going to do is show you how you can set a column to be the index. So let's go ahead and create a new column. We'll say new ind object is equal to, and I'm just going to make a list of states here, or their abbreviations. We'll say California, New York, let's go with Wyoming, Oregon, and Colorado. And I'm just going to say split. And now I have this list here for a new index. And let's create a column. We'll say df states is equal to new underscore ind. Run that. And if we check our data frame, now we have this states column. So let's imagine you just loaded up a file with Pandas, and we'll talk about Pandas data input and output later on. But we just loaded up this file and you're thinking to yourself, man, I would really like this states column to actually be the index. That way I can use these states as a row, since that makes more sense. Well, the way you do this is you simply say df, and you say set index instead of reset index, and then pass in the column you want for the index values. So we say df set index, run that, and here you can see the states. Again, just as always, this is not in place unless you specifically ask it to be. So if we say in place is equal to true, and you run that, now it's permanent. Keep in mind, we did lose our original index. If you don't want to lose your original index values, you should first reset the index up here, and then set the index if you wanted to keep the order of A, B, C, D, E. So that's it for resetting and setting indices. The last thing I want to show you is just a few different ways to get summaries on your data frame. So we can say df info, and that gives us a wide variety of information for the columns, such as what data type they are, how many items are there, their names, how much memory is being used on your RAM. There's also df dtypes, which just shows you the information of the data types for each column. Then there's df describe, and this will give you a bunch of aggregation methods on your data frame per column, at least the columns it can do. So it will give you the count of the items, the mean, standard deviation, the min value, the maximum value, and then the quartiles. So 50% here, that's the median value for each of these columns. If you have string information, such as a list of states as a column, then it's not going to be able to figure out things like the standard deviation of strings, since that doesn't really make sense. So keep that in mind. A lot of these only work on numerical data. Okay, so the very last thing I want to mention here, that's a kind of a quick little trick, is if you were to call one of these columns, so if we take a look at data frame again, and let's say where data frame of W is greater than 0, we get back this series of Boolean values, true, true, false, true, true. If I wanted to figure out how many of these were actually true versus false, then there's a couple of ways I can do this. I can simply assign this as my new series. So I can say something like series W is equal to this Boolean, run that, and then do series underscore W. And there's a method called value counts, which we'll mention again later on, but it can actually then tell us how many were true and how many were false. This is a method off a series. Or something else people like to do is you can check and treat this as ones and zeros, and you can take the sum of a series of booleans, and it will return back the number of trues. And then if you take back the length of the series, it'll return back how many rows there were to begin with. So then you can say length minus sum in order to actually get trues and falses. The reason I mention that is because later on in your exercise, there'll be something that asks you to kind of think of these sort of ideas. So don't worry about this too much now. We'll talk about this in more detail when we talk about operations available with Pandas, which comes towards the end of this section of the course. But for this lecture, just keep in mind that you can set and reset indices using the setIndex and resetIndex command, as well as perform conditional selection on your data frame. Thanks, and I'll see you at the next lecture.